Thank you very much for clicking on this video. I am so much happy and excited to welcome you to SS1 Chemistry First Time Revision Note. This is going to help you a lot if you are from St. Finbar's College SS1. But if you're not from St. Finbar's College SS1, because our scheme is not the same with other people's scheme, it can still be a way to help you. So I urge you to pay attention in preparation of your exam. I'm going to be covering introduction to chemistry, where we define chemistry, we talk about branches and so on. We're going to look into atomic structure and theory, the states of matter and changes, chemical bonding and nomenclature. I am not going to follow it in line, but follow me and let's get this revision done. So I'm starting with the definition of chemistry because it is possible for them to ask us to define chemistry, or they can say what is chemistry or what do you understand by the term chemistry. So we define chemistry as a branch of pure or physical science that studies about matter. Here we are looking into the composition, the structure, the properties and the changes matter undergoes. That's what we're looking at. It will also be good for us to look into how chemistry has been important to the world. So we call it application of chemistry to the world. Sometimes when we ask students to give application, they'll be telling us matches, they will telling us melting of ice. Yes, it is actually application of chemistry, but what we are actually looking at here is medicine, something like drugs, vaccines, antiseptic, food, agriculture, something like fertilizer, preservatives, manufacturing, something like plastic, fuels, textiles, and environment, where we have pollution analysis, water treatment. If you look at, there are some branches of chemistry, but I don't really want us to go too much deep of branches of chemistry. We have organic chemistry that studies about carbon compounds, inorganic chemistry that look into metals, acid, and salts, physical chemistry that look into energy, rates of reactions and equilibrium, analytical chemistry that look into identification and quantification. So you need to have this as the major 4 branches of chemistry we studied this time. So it is possible for them to ask you to mention 2, 3 or 4 major branches of chemistry. So you can give them this and go your way. If you look at the definition of chemistry, we made use of the word matter. And when we say matter, we're actually looking at that thing that has mass and can occupy space. And anything that has mass and can occupy space is rendered to be matter. That means that your pen, your book, your table, your chair, including you, which has mass and can occupy a space, is said to be matter. Matter can be classified based on its physical state, that is the way they appear. Because if you look at the definition of chemistry, we say something about structure. So we are looking at how matter appear. We can classify them as solid, we can classify them as liquid and as gas. Although we still have other ones like plasma and so on, but we are not interested in that. We are more interested in solid, liquid and gas. When we look at solid, the particles of solid are said to be well packed and tightly packed. And this well packed and tightly packed makes the volume to remain the same. And they also have a definite shape because their particle cannot slide over one another. That is why they have definite shape. But they have definite volume because their particles are close to one another. At the same time, because they have definite volume, coming from the idea that their particles are tightly packed, it is difficult for pressure to act on it. So no pressure effect. The tightly packed comes as a result of the strong cohesive force between the particles, and the particles can vibrate and rotate around its axis. Mind you, vibrating and rotating around its axis shows that they have low kinetic energy and they are orderly. Entropy has to do with the degree of disorderliness of a system. So if the disorderliness is high, we say you have high entropy. If the disorderliness is low, we say you have low entropy. For solid, we have low entropy and low kinetic energy. If we look at liquid, the particles of liquid are loosely packed. They have definite volume because the particles are still packed. The particles are not free from one another. That's why they have definite volume. That means that pressure will have no effect on it. They have no definite shape because their particles can slide from one point to another against each other. That is why they can take the shape of the container. The forces between the particles are said to be weak, not as strong as that of solid. Their particles will vibrate, their particles will rotate, and their particles will also translate from one point to another, although they do it in clusters and not just free from one another. That means that they will have higher entropy than solid and higher kinetic energy than solid particles. If we look at gas, we render gas as particles with free movement. So we say that the particles are free to move. Now, because they are free to move, they move away from one another. So they will have no definite shape and they will have no volume. The cohesive force between them are said to be negligible, and they vibrate, rotate, translate, and are free to move randomly from one another. Look at this. Because they move in a haste and in high speed, we will tell you that there's going to be higher entropy in them and they're going to have higher kinetic energy than that of liquid. So pressure can actually act on them because their volume is not definite. Their volume can change because their particles are not close to one another. They are actually free to move. That is why their volume can change. In the definition of chemistry, we also have something to do with changes. So we have two types of changes. One we say physical change and the other we say chemical changes. So when we say physical changes, we're looking at a change where no new substance is formed. It does not always require heat. And we need to know something that it is mostly temporary. Example is melting of ice. But chemical change, new substances are formed and it always involves change in heat. And sometimes we render it as a permanent change. Matter is composed of tiny particles that are always in motion. So when we want to demonstrate this, we can actually use something like potassium tetraoxomanganate in its diffusion, where we are going to put the crystals inside water. We are going to notice that the purple color will spread by itself without us stirring because they are moving randomly from a concentrated part to a position where they have lower concentration. We call it diffusion. So the particles are actually proving to us that they are in constant random motion. When we look at the changes of matter can be changing from one state to another. So we are going to introduce what we call heating curve of solid. If for instance we heat solid, if you look at this my diagram, you notice that from A to B I say it is heating solid. That means that particular time ice is still solid and we are heating it up. But between B and C there is no slant. We have horizontal to the time. That is the curve is horizontal to the time. That means that there is no change in temperature. But between A and B, we are having changes in temperature. The reason why there is no changes in temperature is because at melting point, the energy you are supplying is only doing the work of converting the solid to liquid. So between C and D, we have liquid, and as you are heating it up, the liquid is gaining kinetic energy. When you reach at point D, between D and E, it will start to boil. At that particular point, any heat you are supplying has no effect of increasing the temperature, rather it is doing the work of converting the liquid to gas. We actually call this point latent heat of vaporization, whereas in melting we call it latent heat of fusion. You will understand it better in your physics than here, so I will not stress myself so much talking about this. Between E and F, what we have here is the heating gas. Mind you, it is also possible for these people to ask you to draw the cooling curve of a gas, where the diagram from F to E will be at the left hand side. You know, here it is at the right hand side. It can now be at the left side, as you can see on the screen. Okay, let's look into compound mixtures and elements. When we say elements, we are looking at a pure chemical substance that cannot be broken down into simpler units. Or what I normally tell my students to use is a collection of atoms of the same atomic number. When we look at compound is a pure chemical substance that is made up of different substances that are chemically combined. Majorly we can say element and compound, element, or compound and compound makes up a compound. But when we say mixture, we are looking at a combination of different substances that are physically combined. Element and compound, they are all homogeneous in nature because their compositions are uniform. But mixtures can be heterogeneous or homogeneous. When we say homogeneous, we are trying to tell you that the compositions are in uniform. But majorly, I want us to look into heterogeneous mixture. A heterogeneous mixture is a non-uniform composition, something like sand and water. Sand and water, you're going to notice that there are two layers, one that is partially colorless and one that have a color that goes towards brown. And if we want to separate this sand from water, there are processes we can take. We call it separation techniques. One, we add water to the sand and salt mixture. What we are doing here is what we call dissolution of this mixture. Now, when we add it, we notice that the salt, if it is sodium chloride, it will be soluble, whereas the sand will not be soluble in water. So we are going to present a filtration process, as you can see on the screen. So the beaker will contain the mixture, so we pour it inside the filter paper. So the filter paper is going to hold the sand because the sand is serving as the residue, whereas the funnel is where the water is going to pass through. We are directing the water so that it will not fall off, and the filtrate is going to be the salt solution passing through the filter paper. I always urge my students to use conical flasks to do filtration rather than using beaker. So you need to know that. So the one that crosses is the one that passes through the filter paper, we call it filtrate. The one that is being held by the filter paper, we call it the residue. So in the process of sand and salt, the sand serve as the residue, whereas the salt solution serve as a filtrate. And after we have gotten the sand, we can dry it. Our sand is gotten, but our salt solution, we need to recover it using a process we call evaporation to dryness, which you can see on the screen. This evaporation to dryness, what happened here is that we are going to heat up this substance. We are going to heat up this solution. When we heat up this solution, what happened is that the liquid portion of this mixture is being removed from the mixture. So what will be left is the salt. But there's another thing that look like this. There's another diagram that look like this. We call it distillation. In distillation, what we do is that we are interested in recovering a liquid. Where we heat up the liquid become gas, and the gas is cooled again and collected through a condenser. That particular liquid we get from this, we call it a distilled liquid. It is also possible for us to use distillation to get ethanol and water. The boiling point of ethanol is 78 degrees Celsius, whereas the boiling point of water is 100 degrees Celsius. That means that when we are heating this mixture, ethanol, which boils at 78 degrees Celsius, is going to come out first. The reason being that is its boiling point. It does not mean that there will not be a little drop of water coming out, but more of the ethanol will come out. So how are we going to know that the quantity of ethanol present in that particular mixture has been removed? The only way to know that is to look at the thermometer. When the thermometer moves from 78 degrees Celsius to something like 80, 85 and so on, that means that all the ethanol has been collected. So we can remove the conical flask and introduce another conical flask to condense or get a distilled water. But if you look at this, my diagram is talking about salt water. When we say salt water, we are trying to tell you that a soluble salt in water, we are trying to recover back this water, not the salt. So we heat it, the water is now evaporated, becoming gas. So we collect it through a condenser. It is possible for your examiner to use this as a diagram and ask you to fill it up. So if I were you, you make a diagram of this, draw it up to 10 times. You will see that you will master it after drawing it by looking at it. Let's look into atom. When we say atom, we are looking at the smallest part of an element that involve in chemical reaction. I know you say take part in chemical reaction. They are all the same. And these atoms we are talking about, there is a theory we call Dalton's atomic theory. It says that matter is made up of indivisible atoms. Atoms of the same element are identical. Atoms of different elements differs. Compounds are formed by atoms combining in simple whole number ratios. And atoms rearrange in reactions. That does not mean that they are created or destroyed. These are the ideas coming from Dalton's atomic theory. Mind you, this theory is no longer held strongly in chemistry because we have discovered some things about atoms. Something like, we know there are subparticles of atoms like protons, neutrons, and electrons. We know that protons are found in the nucleus, just like neutrons are found in the nucleus of an atom. But the electrons are revolving around the nucleus, which we can call shell orbit, or found in the orbital. The charge of this proton and electron is +1 and -1 respectively, but neutron is said to be 0. The relative mass of proton and neutron is said to be 1, but that of electron is said to be 0.005. You have to know this. It's very, very important and crucial. If you look at atom, each atom is said to be unique, or each atom of an element is said to be unique based on the number of protons in the nucleus of the atom. Because the number of protons in the nucleus of an atom identifies the atom of the element. For instance, if we have atomic number to be 1, we will say it is hydrogen. If it is 2, we will say it is helium. If it is 8, we will say it is oxygen. We also need to know another property of an atom called mass number. This mass number has to do with the sum mass of protons and neutrons in the nucleus of an atom. Although we can also call it nucleon number, where we are adding the proton and neutron. Mind you, when I say nucleon, I'm trying to tell you the major particles that are found in the nucleus of an atom. Look at this. We can actually have atoms having the same atomic number but different mass number. We have example of them in carbon and also in hydrogen, and many elements has their own isotopes. So that means that they will have atoms of the same atomic number but different mass number. You have to know that something like that exists. Okay, so I want you to look closely to the diagram of the oxygen I have here. You notice that there's a place we call the nucleus, which is serving as the center of the atom, and around it we have 2 electrons in the K shell, and outside the K shell we have 6 electrons at the atomos shell. The 6 electron at the atomos shell is what we call valence electron. So oxygen has 8 protons, 8 neutrons, and 8 electrons. If we want to write the electron configuration, we can say the electron configuration of oxygen is 2s. Sometimes I tell my students, for you to write this electron configuration 2s, it is in a haste. The best thing for you to do is to start it from SPDF. So in SPDF, oxygen is said to be 1s2, 2s2, 2p4. I don't really need to come and teach you this. I'm just reminding you what you have known. When we look at sodium, it's 1s2, 2s2, 2p6, 3s1. For chlorine, it is 1s2, 2s2, 2p6, 3s2, 3p5. When we say magnesium, we are going to have 1s2, 2s2, 2p6, 3s2. Note, the number as superscript are said to be electron. The number before the letter are said to be the energy level, whereas the letter are said to be the subshell or the orbital. For instance, 1s2 is telling us that energy level 1, we have a subshell carrying 2 electrons. So if we want to convert this SPDF to K element, we are looking at the energy level. For oxygen, in energy level 1, we have only 2 electrons. But in energy level 2, where we have 2s and 2p, we have 2 electrons and 4 electrons joined together to give us 6 electrons. If we do the same thing with sodium, chlorine, and magnesium, we are going to have 281, 287, 282 respectively. There is something I want to tell you. The last numbers we are calling in the electron, that is the 6, 1, 7, and the 2 in magnesium at the extreme, is what we call the atomos electron. This atomos electron has a special name called valence electron. So valence electrons means the number of electrons at the atomos shell. Wait. This valence electron sometimes can also be called the valency of the element. For instance, magnesium valency can also be 2. Sodium valency can also be 1. Oxygen valency can also be 6. But because most times it is found as the highly electronegative in a compound, we will say that it's going to accept 2 electrons and become negative 2. So we are looking at the number of electrons is going to accept rather than the number of electrons is going to give out. That is why most times we say the valency of oxygen is 2. Look at this. If you look at magnesium, previously we have it as 2H2, and I say it is its valency. So it is possible for magnesium to lose these 2 electrons and become Mg2+. Now for me to find the valency of an ion, what I just need to do is to remove the sign. That 2+, remove the plus, it becomes 2. Aluminum 3+, we just remove the plus, it becomes 3. SO4 2-, remove the minus, it becomes 2. So what do we mean by this word valency that I've been talking about? Valency represents the combining power of an atom, element, molecule, or ion. There are some molecular ions like NO3-. We also call them polyatomic ions. We can call it nitrates for common name or old names. But IUPAC name of this is triazonitrate 5 ions. SO4 2-, old name is sulfate, but currently using IUPAC name we can call it tetraazosulfate 6 ions. There are some compounds I would like you to look into. Sodium chloride, where we have sodium and chlorine joined together. We also have sodium triazocarbonate 4. We have aluminium oxide. Note how we form this aluminium oxide. It is very, very important. The bond that exists between metals and non-metals due to electron transfer is what we call ionic bond. But if you look at most bond that exists between non-metals and non-metal is occurring by sharing of electrons, and we call it covalent bond. We can see that majorly in carbon atoms. Note this. For you to form ions, the process of forming ions from atoms by transfer of electrons is what we call ionization. You need to know that for precise volume measurement, use burette. To measure temperature, use thermometer. To look into something that is very, very minute, we can use microscope. SI unit of mass is kilogram. SI unit of volume in chemistry is dmq. So we have some elements that their names and their symbol does not look alike. Something like lead, plumbum, Pb, copper, cuprum, Cu, mercury, hydra, gyrum, Hg. These names I called are from the Latin names of these elements. Do you know there is a difference between evaporation and boiling? In evaporation, it occurs at any temperature, surface of the liquid only, and it is slow. But for boiling, it occurs at the fixed boiling point temperature and occurs throughout the liquid, and it is fast. So that's a way we can use to differentiate between boiling and evaporation. It is possible for them to give you an atom, the nuclei of an atom, and ask you to calculate the number of protons, the number of electrons, and the number of neutrons. For instance, we can have something like atomic number of chlorine to be 17 and mass number to be 35, and you are now asked to find the number of protons, the number of electrons, and the number of neutrons. You need to know that atomic number for an atom, which we know that atom is a neutral particle. So the atomic number being 17 protons is also going to have electron to be 17. So if we are looking for the number of neutron, we go to the mass number, because the relationship between proton and neutron is found in mass number. So 35 minus 17 will give us 18 neutron. I really thank you for watching this video to this extent, and I urge you to listen to this video 3 more times, then write out everything you have seen in this video and what you have heard. Make sure you write it 5 times in a book. Write it the first time, look at it and write it the second time, look at it and write it the third time, look at it and write it the fourth time, look at it and write it the 5th time. When you are done with this instruction, you are very prepared for writing this chemistry exam. I wish you good luck.